The Earth's atmosphere is a relatively thin layer of gases surrounding the planet. Approximately 300 miles thick, about 80% of the atmosphere is within 10 miles of Earth's surface. There is no exact place where the atmosphere ends. It just gets thinner and thinner until it merges with outer space. Today's atmosphere is probably not Earth's original atmosphere. The Earth's atmosphere was most likely formed by planetary degassing, a process in which gases were released from the interior of the Earth via volcanic eruptions and other activities. Life forms on Earth have modified the composition of the atmosphere since their evolution. The atmosphere is an important part of what makes Earth livable. The atmosphere insulates the Earth from extreme temperatures by keeping heat inside the atmosphere and blocking much of the sun's incoming ultraviolet radiation. Two gases make up the bulk of the Earth's atmosphere: nitrogen, which comprises 78% of the atmosphere, and oxygen, which accounts for 21%. The other 1% is composed of trace gases, the most prevalent of which is the inert gaseous element argon. The rest of the trace gases, although present in only minute amounts, are very important to life on Earth. Two in particular, carbon dioxide and ozone, can have a large impact on atmospheric processes. Another gas, water vapor, also exists in small amount. Water vapor varies in concentration from being almost non-existent over desert regions to being about 4% concentrated over the oceans. As the sun's solar radiation enters Earth's atmosphere as visible shortwave light, approximately 30% is reflected back into space, while the remaining 70% passes through. Of the 70% passing through the atmosphere, 3% is absorbed by clouds, 16% by atmospheric gases, and 51% by the land masses and oceans. During the absorption process, the solar energy is transformed into heat or thermal energy. Once the transformation into thermal energy occurs, the thermal energy becomes available for re-entry into the atmosphere through a process called infrared radiation. Without any barriers, however, the heat would just as quickly escape out to space. Certain trace atmospheric gases are transparent to incoming visible shortwave light, but act as a barrier to outgoing infrared, longwave, or thermal radiation. In other words, the radiant energy can pass through the atmosphere, but the thermal energy cannot. This net flow of energy into and out of the system is Earth's energy budget. When the flow of incoming solar energy is balanced by an equal flow of heat to space, Earth is in radiative equilibrium, and global temperature is relatively stable. Anything that increases or decreases the amount of incoming or outgoing energy disturbs Earth's radiative equilibrium. Global temperatures rise or fall in response. The theory that gases in the atmosphere might increase Earth's temperature was first postulated by Joseph Fourier in 1827, but it wasn't until 1896 that savant Arrhenius quantified the theory and coined the term greenhouse effect. Many greenhouse gases occur naturally in the atmosphere, while others are synthetic. When greenhouse gas concentrations increase, Earth temporarily traps infrared radiation more efficiently, so the natural radiative balance is disturbed until the surface temperature rises to restore equilibrium between incoming and outgoing radiation. The major greenhouse gases are carbon dioxide, methane, nitrous oxide, and the fluorinated gases, chlorofluorocarbons, hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride. Carbon dioxide is produced naturally through plant, animal, and human respiration and volcanic eruptions. Carbon dioxide is also the product of the oxidation of carbon in organic matter, either through the combustion of carbon-based fuels, coal, natural gas, oil, solid waste, trees, and wood products, or the decay of biomass. Carbon dioxide is also emitted as a result of certain chemical reactions, such as the manufacture of cement. Carbon dioxide is removed from the atmosphere or sequestered when it is absorbed by plants as part of the biological carbon cycle and fixed in land and ocean sinks, natural carbon storage reservoirs. Carbon dioxide in the atmosphere varies throughout the year, decreasing slightly during the summer as plants leaf out and increasing during the winter as plants go dormant and photosynthesis decreases. Methane is produced naturally when organic matter decays, for example in wetlands and rice fields, during wildfires, and from animals. Methane is also emitted during the production and transport of coal, natural gas, and oil. as a result of industrial livestock and other agricultural practices, and by the anaerobic decay of organic waste in municipal solid waste landfills. Methane emissions are also expected to increase through the melting of methane ice, now buried under the ocean floors, and through thawing of permafrost. Nitrous oxide is produced naturally as a byproduct of nitrification and denitrification in the soil and oceans and by lightning. Nitrous oxide is also emitted from nitrogen-fertilized soils and livestock waste during the combustion of fossil fuels and solid waste and as a result of wastewater treatment. Nitrous oxide is used in surgery and dentistry for its anesthetic and analgesic effects. Fluorinated gases, F-gases, are not produced naturally. F-gases are synthetic greenhouse gases emitted from a variety of industrial processes, mainly as substitutes for ozone-depleting substances such as chlorofluorocarbons, hydrofluorocarbons, and halons. Hydrofluorocarbons, HFCs, are typically emitted in coolants in refrigeration, air conditioning, and heat pump equipment, in blowing agents for foams, from solvents, and from fire extinguishers and aerosols. Perfluorocarbons, PFCs, are typically emitted by activities in the electronics sector, for example from plasma cleaning of silicon wafers, as well as in the cosmetic and pharmaceutical industries. In the past, PFCs were also used in fire extinguishers and can still be found in older fire protection systems. Sulfur hexafluoride is typically emitted as an insulating gas in high-voltage switchgear and in the production of magnesium and aluminum.